you ever wanted to make pixel art, you likely use programs like Sprite, Photoshop, or even one directly in your browser. But using pre-made programs is boring, so today I will show you how you can make your own pixel art editor. It won't be nearly as good as Sprite, for example, though it will have the most basic features you need to start drawing. I am using Rust, but you can follow this video in every language, as it will be quite straightforward to translate it, because I'm not gonna show much code. Every pixel consists of 4 values: a red, a green, a blue and an alpha value. In this example, every value apart from A is 0. You can combine these 4 values to create every single color you need. This means you can represent every image you draw as a 2-dimensional vector of those 4 values, where every value is an 8-bit unsigned integer, perfect for what we need, as it ranges from 0 to 255, exactly at the range of RGBA values. I used EGUI for Rust to create the user interface. The canvas is just a rectangle consisting of a grid that I can toggle on or off. When I click with my mouse to draw, it calculates the grid position, adds the RGBA value I selected on the left to my 2D array of pixel data at the grid position, and then draws a rectangle at this position. For performance improvements, I am only drawing the pixels that have an alpha value of more than 0. This program has already its most important feature, the drawing of pixels. Now we want to save this beautiful artwork, so we need a buffer, here represented as a struct called image. This buffer needs the width and height of the drawn image in pixels. We are using unsigned integer types because there won't be any negative values, so it's pointless to use normal integers. I actually used U16 as this has already more than enough space, ranging from 0 to 65,535, which is more than enough for me, but the most commonly used type is U32. If you use U32, the width and height will be 4 bytes each, and then you need the pixel data, but this time as a 1-dimensional array of 4 values, each one having 1 byte. You could also just use the 2D array, but it is much easier to save in 1-dimensional array. You can also add stuff like the palette you're using if you add one, but right now it doesn't need much more. This is the save function I wrote. It takes the image and the path as arguments. Here I add .pix to the path, but that means that you don't want to add the ending in the path you provided as the argument. I am using fs::file from the standard library of Rust, but you can use whatever you like. This is just used for writing to the file. And then the width, the height and the pixel data gets written to the file. Keep in mind, this is only the save function. It is not exporting it, so you can choose pretty much anything as the file ending. I also did not properly handle errors in this function. You can add this yourself. Now we want to read this file again, so here's the load function. You might be thinking, oh no, so much code. Don't worry, it is pretty easy. It just reads the values from the path in the order we saved them, this time with error handling. For the pixel vector at the bottom, you don't need to create it like this in Rust, because it is a vector, but like this I can show you much more easily how big it is, and some languages like Java don't have vectors. And then it just returns the image or an error, which can be handled when you call the function. Another thing to keep in mind is that in this example code, I set the size of width bytes and height bytes to 2 bytes because I used the U16 as the width and height. If you use U32, you have to specify 4 bytes. If you call the function, you just need to convert the 1-dimensional array into the 2-dimensional array and set the canvas size and so on. So this is what it looks like in my case. Not very pretty, I know, but it fulfills its job. I didn't manage to open the file explorer, so you have to manually type in the path of your file. Here you can see how I draw something beautiful, save it after it's finished, draw something else and then load it again. Obviously, a pixel art editor needs more tools than just a 1 pixel big sized brush, so I added a brush size slider, an eraser, basically a brush that just draws with all values set to 0, and a fill tool. The brush now draws in a very rectangular circle around the grid that got clicked, and the fill tool iterates over the pixels radiating out from the mouse, checking if the adjacent cell has the same RGBA value as the grid cell of the mouse, and replacing it with the selected RGBA value. You also might want to have the option to export your image as a PNG file and import other PNG files to use them inside the editor, so I added this functionality as well. This time I didn't write the code myself, as there are a lot of things to add if you want to write or read a PNG file. I just used the image crate in Rust to do this job for me. This means that this editor has the most important functionalities now, that you need to create your own artwork. There are a lot of functionalities that need to be added until I would prefer to other editors. A big performance issue that would need to get fixed as well is that you can't really go much bigger than 150 by 150 pixels as a canvas size without lagging, because every single pixel gets rendered individually, which leads to performance drops. This could be fixed by batch rendering. That means if there are pixels next to each other with the same RGBA values, they get drawn together, not individually like what's currently the case. This is not the only thing that needs to be fixed, but for now I would end the video.